Hello, my name is Jack Armstrong, and I'm going to be presenting today Graphite Polystyrene and Energy Code Compliance. This program has been approved for a 1/2 credit health safety welfare with American Institute of Architects. This is copyrighted material by BASF Corporation. As I mentioned, you will be receiving credit for this course today. Additionally, I wanted to let you know that in the previous program, Not Your Grandmother's Vinyl Siding, we learned about the advantages of graphite polystyrene insulation vinyl siding as a high-performance building system. But today, we're going to be discussing how this system can help achieve the requirements in recent model energy codes as well as standard updates. So this is considered a nano course, if you will, and an adjunct into the larger course, which hopefully you have already had. That would be a kind of prerequisite, if you will, for having already completed the Not Your Grandmother's Vinyl Insulated siding advantages of graphite polystyrene insulation. Today's learning objectives are going to be defined around understanding continuous insulation and how graphite polystyrene insulation vinyl siding serves as continuous insulation. Secondarily, identifying and explaining the differences between some of the national codes as well as municipal codes and how they utilize these continuous insulation or CI requirements. And lastly, being able to locate where 2021 International Energy Conservation Code, residential as well as commercial ASHRE 90.1 codes have already been adopted. So kicking off right into it with the continuous insulation CI, as I mentioned earlier, and graphite polystyrene insulated vinyl siding. We're going to hit on what is it, what problems does CI address, and how does graphite polystyrene vinyl insulation provide a solution? First of all, what's the problem? Well, the problem is what we call thermal bridging. So as we talked about in the larger previous class, stud framing actually creates a problem. Every time you have a stud wall in your cavity light frame construction, that's a place where there's no room for insulation. And if you add up nominally every 16 inches on center, or in advanced framing every 24 inches on center where you have a stud, that's a place you don't have insulation, a space for insulation of the wall. And so if you add up all of those support structures on the external thermal envelope, that's about 25% of the wall area is taken up by the wood structure. And there's no place for the insulation to go in that, only say the remaining 75%. So that's what we mean by framing factor, or a 25% surface area of the walls being taken and no room for insulation. And what that creates is, when you look at this picture to the right, you actually see in the thermographic image the heat loss due to the thermal bridging of the studs. And you can see these vertical members up and down here, where the heat from internally the building is kind of leaking through as a thermal bridge through the wall assembly. And this is the reason why there is a requirement for continuous insulation in many of the climate zones across the country. Additionally, in this particular case, you can probably see where in the upper portion of this photo, it's a little bit redder, and that's where the cellulose insulation or the fiberglass bad insulation that is in the cavity has actually settled, and you're getting more heat loss there. Continuous insulation is built to remedy this particular situation. So, CI, as we mentioned, oftentimes it's called, or just continuous insulation, is essentially the idea of insulation running like a thermal blanket all the way around the exterior portion of the building, and kind of blanketing the building and overcoming those short circuits of where the studs are. And as you can see in this photograph, you can see the image of the stud wall construction. and some cavity insulation. But on the external side of the wall, you can actually see this graphite polystyrene backed PVC siding. And this is where we're getting benefit of the continuous insulation. And so when energy is trying to leak out, we have our R value, that's the resistance to heat flow, and it's stopping and minimizing that amount of energy loss with continuous insulation. Graphite polystyrene vinyl siding is one step siding solution and also continuous insulation. So you get, a 2-for-1. You get a siding product as well as an insulation product, as well as satisfying the requirements the code asks for continuous insulation. And as we discussed before, you can see a large in the left here piece of thermal bridging going on traditionally in stud frame construction, where the 25% framing factor is involved. And then afterwards, once the continuous insulation has been installed, those thermal bridges go away and you no longer see that loss. So kind of reminding where we left off from the larger 1-hour presentation before we dive into some of the code-specific issues. The siding products on their own, where you can see here to the right, stone has a very small R value as a cladding product, as a siding product. Stucco also 0.1, brick 0.1, fiber cement siding 0.15. Vinyl siding by itself with no insulation on the back is better, but it's still just 0.6. Wood sheathing 0.8. However, vinyl insulated sheathing is an extremely improved value of a R2 to R3.5. And that's really the benefit of this product and satisfying its continuous insulation. So how does that really work with energy codes? What does it mean to say International Energy Conservation Code? Which codes require continuous insulation, CI, and where have they been adopted? Well, I am glad you asked. Let's hop right into it. So IECC, or International Energy Conservation Code, is essentially what's considered a model code. So in the United States, the model code for commercial buildings is called the ASHRE 90.1. So American Society for Heating, Refrigeration, and Air Conditioning Engineers. And it's considered the model code through most of the states. And additionally, there are other standards that are sometimes adopted or not adopted by various states. The latest code is the 2021 cycle. We are getting ready to go into the 2024 cycle, but pretty much ever since 2009 into the 2012 cycle, as well as 2015 and 2018, as they're updated every 3 years, continuous insulation has been a mandated element in the prescriptive path for overcoming these thermal bridges from the high framing factor in walls. It is a minimum standard for energy efficiency. And just to let you know that the commercial code, or this ASHRE 90.1, is considered what we call commercial. It's 4 stories and above. It's not considered low rise. So as you can see here in the center, ASHRE 90.2, which is the IECC provisions for residential structures, actually picks up at 3 stories, 2 stories, and 1 story. And the last portion here, IECC can add additional requirements on top of the ASHRE requirements to make it even a little more stringent. Oops, I went one too many there. And lastly, the standards can be adopted and modified by any particular jurisdiction. So what that means is a state can adopt portions of them, a city, a county. So it's not always adopted in the complete fashion with which it was offered as a model code. Now, most states have adopted these statewide building codes, and they automatically apply to every community in the state, but not always. Some states have statewide codes, but they let local jurisdictions decide whether or not they want to enact it, or they can opt in or opt out to certain portions of it. Additionally, some states have no statewide building code at all and leave it entirely up to the local jurisdictions. Additionally, some specific state energy codes exist, as we can see here. Say in California, you have the Title 24 codes. In New York, you have the New York state codes. There are other states that have no codes at all. So Missouri has no statewide building code, and the codes are only adopted at local levels for the local towns or jurisdictions or counties. Arizona, very similarly, operates on the same way. So building codes are optional in many parts of the country, which isn't always the best thing as far as energy efficiency. So what are some of the things to just keep in mind and learn from when we talk about codes? Well, my favorite is to start over here in the upper right-hand corner and remember that codes are a minimum. Codes are what's called, it mandates the worst building you can legally allow by law. So building to code isn't necessarily something you want to be proud of. It just means you're meeting the minimum standards for performance. So that's a really low threshold. Secondarily, codes almost always get more stringent and get tougher. So being able to not build to a code minimum building today is important, because in 3 years when the new cycle comes, that building would be illegal to build. So the idea of being above code minimum is always a good thing. Each time the new code cycles do come out, they must pass before being enacted a Department of Energy 10-year payback cash flow analysis to make sure that all the items that are in the code actually make sense, and over a cash flow perspective of 10 years would pay for the cost of implementing those particular objectives. Otherwise, it's not adopted. And lastly, almost always the monthly cash flow overall of the implemented item, as well as the energy cost to run that particular building, is positive or neutral. Otherwise, the code elements do not get adopted into the model code. So where is the new continuous insulation requirement in the residential code for the International Energy Conservation Code? Well, I'm glad you asked. It's actually in what we call the prescriptive pathway, because there's 4 ways that we can qualify to meet the code. And as an example, you can have the prescriptive path all the way here to the left. You can have the performance path here in the center. You can have the energy rating index path, which is essentially the energy modeling performance calculations energy modeling path. And then there's a new version, a new path for tropical climate regions. In the prescriptive path area, that is where continuous insulation can be mandated. And many times there's no trade-offs, or there are some trade-offs with individual components through this overall U-factor methodology. So what does that really mean? Well, let's kind of zoom in. And in the prescriptive method, in order to have very well insulated walls and roofs and perform adequately and overcome that thermal bridging that we were talking about, we have, of course, our various climate zones, as you can see here to the left across the country. And I have a map coming up so we can see those, where those are. Then we have the mandated amounts of insulation for attics, for floors, for the walls, and but depending on the climate zone, for example, if you're in climate zone 1, which is the southern part of the United States, kind of Florida and southern Texas, you're required to have an R value of R13 in the wall, specifically in the wall cavity. Or if you don't put insulation in the cavity, you can put it all externally as an R10 of continuous insulation. But as you get further up into the middle of the United States in climate zone 3, you have to have an R20 in the cavity, which means you have to have a thicker wall, not a 4.5-inch wall, but probably a 6.5-inch wall. Or you can have the code minimum insulation in the 4.5-inch wall plus continuous insulation of R5. Or you can say, hey, I'm not going to put any insulation at all in the cavity, R0, and I'm going to put it all externally on the outward side of the wall, with an R15 continuous insulation. And so you can follow through how the chart goes here. Here is a chart of how the adoption is for the current codes. So over here on the far right, you can see the various code cycles, the 2021 cycle, 2018, 2015, and then by color, you can actually see which percentage of the country by residential floor area has adopted. And so 48%, as you can see, are still on this 2009 code. That's kind of this orangish color. You can see the majority of states are there. California, Washington, Vermont, you can see are part of this 13% that are the most current code, 2021, and others are kind of somewhere in between. Now, this was the map I was showing you earlier, where you can actually see the various climate zones across the country by color. And in the lower right-hand corner here, you can see the various zones, 1, 2, 3, 4, 5, 6, 7, 8. And this one is actually a map of the commercial requirements, or ASHRE 90.1. Just so you know, ASHRE 90.1 was first adopted back with continuous insulation back in 1999. So they've been doing continuous insulation much longer than the residential code has. And again, as a reminder, the commercial code is 4 stories and above all buildings. So let's talk a little bit about federal incentives and some money in your pocket for building energy efficient buildings. So recently, the Infrastructure Investment and Jobs Act set aside a lot of money. And so you can see 245 million here from the Department of Energy to try and help the states and municipalities adopt these newer codes. Then additionally, the IRA also had $1 billion set aside for other efficiency measures. There are a variety of tax incentives that are available, things like 25C, 45L, 179D, and many of those are all going to help add both tax credits or tax deductions for your ability to be able to get some incentives to improve. Additionally, grants are expected through 2029. So you have a nice amount of time to qualify for some of these particular funds. Additionally, HUD requirement, Housing and Urban Development, are actually strengthening some of the requirements that they have for what the reference benchmark is if you want to have like VHA loans, VA loans, and FHA loans. Those are going to be reindexed to build to the minimum 2021 standards. And there is discussion also of having to start to build to higher code levels at a minimum value if you'd like to be able to sell those loans to the government-sponsored entities of like Fannie Mae and Freddie Mac. Otherwise, those particular loans and home mortgages would have to stay at the local banks that originally rendered them out. So today, we actually want to talk a little bit about the idea of how various superior continuous insulation qualifies for vinyl-backed GPS insulation. And the whole notion to actually make sure you understand is that you indeed do qualify for continuous insulation. And so this little spotlight on what the codes say and where they're required was really meant to help you just understand further the nature of how the codes are put together and what it really means to build code minimum or in an advanced code situation. Next to last, I wanted to share with you once again the suite of courses that are available. So the main course, the 1-hour course, the umbrella course, if you will, that was kind of a prerequisite for this nano course, was Not Your Grandmother's Vinyl Siding, Advantages of Graphite Polystyrene Insulation. And that one is a full one learning unit credit of health, safety, welfare. And then today we discussed the energy and code compliance portion of the nano course. So now let's go ahead and finish off by some resources that you can use in the event that you'd like to have further information. So additional links for SpecLink, MasterSpec, continuousinsulation.org, BidSpec. Also, the Foam Sheathing Coalition has a variety of information that's available to you. In addition, progressivefoam.com, neopor.us, the master format division actually has additional information, as well as some programs called Sustainable Minds. And so I hope this spotlight on some of the codes and what it really meant is helpful for you. And if you would like to have additional information, please feel free to reach out to Ron Height at BASF. His email is available here as well as the website. So thank you for your time. I look forward to being able to share other courses with you as they become available. Thank you and have a good day.